Hi, Assalamualaikum to our Dr. Zikri. So today we will present to you on our Lab 2 report on construction of AC high voltage generation and measurement referring to the YouTube channel that Sir have provided. So I have with my partner three person, Muhammad Syafiq Aziz, myself on Mahaziz, and my other friend is Farha Sabrina. So let's continue. For section 1, this is a description that have been provided in the lab too. So we must take either one of these what the equipment that we will use, and based on the YouTube channel and based on the understanding, we have determined that the equipment that we will use in this lab too is the test transformer 100 kV, the measuring capacitor, the grounding switch, the top electrode, the connection rod, the connection cup, flow pedestal, spacebar, and secondary part for CM on AC circuit. So this is the equipment that we will use. We will continue to our friend Farha Sabrina.
Assalamualaikum. My name is Farha Sabrina. Today, I'm going to present on Lab 2 for high voltage. My section is in section 2. Draw the connection circuit between FC to the transformer tap point. This is the high voltage conductor. This is driver 1 and this is driver 7. This is basic model UB1 and basic model UV7. This is the high voltage side and this is the low voltage side. For isolation transformer, it is very important to use isolating transformers when an oscilloscope measures signals in an electric circuit which is not galvanically isolated from the network. It is used as safety and protection of electronic components and the persons against electric shock. For question 2, next is to assemble the basic components with the connection from transformer to the capacitor for the measurement. This is the high voltage terminal, capacitor 1 and capacitor 2. This is inductor. This is the secondary terminal and this is for secondary terminal. The device consists of 3 parts. 2 capacitors across which the transmission line signal is split, an inductive element to tune the device to the line frequency, and a voltage transformer to isolate and further step down the voltage for metering device or protective relay. For question 4a, capacitive divider for the measurement by considering high voltage level to a lower voltage level. The capacitive voltage transformer is used to step down the high voltage input signals and provide the low voltage signals which can easily measure through the measuring instrument. The capacitive voltage transformer can also be called capacitive potential transformer. This is the circuit for capacitive potential transformer. This is capacitor, inductor. This is the resistive load and terminal for controlling. For capacitor 1 should be higher than capacitor 2. The capacitor that is placed near to the ground have high capacitance as compared to the place that is near the transmission line, this one. The high value of capacitance means the impedance of that part of the potential divider becomes low. That's all. Thank you.
To continue, the question that we not answer yet. This is another question. That's section 2 on number 3. There are some of what people say the description that I can tell you based on our understanding. That is, there are 2 points at the banana equipment that is grounding an inner point so that they connect with the binti part to make sure the correct connection. So the banana have such a part ear that we can see in the faces of the area that have ear that represent as a ground that we connect as an outer pointer, as we can see on the picture. And with the banana, another point will be connected to the inner point as the binance at the binary female. So as we can see at the picture, there are 2 points for our connection with the BNC coax cable. So as we know, the capacitor is given as 2 microfarad that represents on the manual and specification of the secondary unit itself. So this you can see on this secondary unit actually consists of specific capacitance rated. So here as you can see, based on the Dr. Zikri, we have made sure that serial number first and make a note on the rated voltage for the secondary unit. Also the rated capacitance on the secondary unit. Then we will note at the measured capacitance to make sure what what our secondary unit have been used, because every secondary unit consists of different serial number and maybe can consist of different rated capacitance. So we do not want any damage happen on our equipment, so we must make sure that first. So for the last question, this is a circuit that I have conduct on the secondary unit. That the secondary unit for the AC divider which incorporate the LC capacitor connected between the shaft socket of the measuring capacitor CM and the DM15551 or periscope by means of coaxial cable that I have referring from the manual book of heavily hypotronic. So after the calculation, I will be make sure that every single of the capacitor to make as a 20 microfarad at 2 microfarad, they have considered one of the capacitor in series and be connect as every each of them is 40 microfarad. So if we total that, we can get 2 microfarad. So when we connect it with the system, there will be a resistor to make sure of it, and also then we can use the equipment. Thank you. And we proceed with Syafiq Aziz.
Assalamualaikum and good day to Sir Zikri. Today I will present about coaxial cable and the connection of the apparatus that we use at the lab. First of all, my name is Muhammad Syafiq Aziz bin Azizi. I am from BAI section 1/2. Okay, for the coaxial cable, the different coaxial cable have different impedance. Most coaxial cable have a characteristic impedance of either 50, 52, 75 or 93 ohm. The RF industry use standard type names for the coaxial cable for 50 ohms. The 50 ohms cable is larger connector and thicker cable housing. The 50 ohm cabling is quite noticeably bigger than 75 ohm cabling. Then this is the connection for the frequency converter, floor pedestal, measuring capacitance and secondary capacitance. The connection from frequency converter is from grounding switch to the floor pedestal, and floor pedestal have been attached to the measuring capacitance because the switching ground need to touch the top electrode to make the current and voltage through the measuring capacitance. Then take the coaxial cable 50 ohms, connect from measuring capacitance to the secondary unit capacitance. add the female connector to the male BNC coaxial cable. Before connect the coaxial cable, we need to make sure that the female connector and ground point is connect wisely at the secondary unit capacitance. The other side of secondary unit capacitance is connect to VM1 at the frequency converter using the other coaxial cable. The floor pedestal that attached to the measuring capacitance will connect to the grounding switch at the frequency converter. For the grounding, we need to attach from frequency converter, floor pedestal, measuring capacitance, and secondary unit capacitance. One more point, the VM1 at the frequency converter is allow maximum 7 volt RMS through it, and it used for AC connection. That's all for me, and this is the end for the lab session. Thank you.